What if computers could use light instead of only electrical signals to process information? This is the fascinating idea behind photonic chips, computing with light. Today's computers mainly process information using electronic circuits. Electrical signals move through transistors and wires to perform calculations and move data. But as chips become faster and more powerful, electrical connections face challenges such as heat, energy consumption, and limits on how quickly data can move. Photonics takes a different approach. Instead of moving information only with electrical signals, photonic systems use particles of light, called photons, to carry information. A photon is a quantum particle associated with light. In photonic computing, light can carry information through tiny optical structures built into a chip. Inside a photonic chip, light can travel through tiny structures called optical waveguides. These act somewhat like pathways that guide light across the chip. Just like electrical signals can represent digital information, properties of light can also be controlled to represent and carry data. Light can travel extremely fast and can move large amounts of information through optical channels. This makes photonics attractive for high-speed communication and computing. Another advantage is parallelism. Multiple light signals can travel through different optical pathways at the same time, opening new possibilities for processing and communication. Photonic chips could help computers move and process information faster, while potentially reducing some of the energy and heat challenges found in traditional electronic systems. A photonic system first needs a source of light. Lasers are often used to generate controlled optical signals that can carry information into the chip. Tiny optical waveguides then guide the light through the chip. These structures are designed to control where the light travels. Photonic circuits can manipulate light in different ways. Optical components can split, combine, redirect, or change light signals as they move through the chip. One powerful concept is optical interference. When light waves interact, their combined pattern can be used to perform useful mathematical operations. By carefully controlling these optical interactions, photonic chips can perform certain mathematical operations using the behavior of light itself. One exciting application is artificial intelligence. Photonic computing could potentially accelerate some of the mathematical operations used in neural networks and machine learning. Data centers process enormous amounts of information. Photonic technologies could help move data between computing systems more efficiently, potentially reducing communication bottlenecks. Photonics is already important in communications. Optical fibers use light to carry huge amounts of data over long distances, and photonic chips can help process those optical signals. Photonic chips are not necessarily replacing electronics completely. In many systems, the future may combine electronic circuits for control with photonics for high-speed data movement and specialized. This hybrid approach could offer the best of both worlds. The flexibility of electronics combined with the speed and parallelism of photonics. One of the most promising applications is AI acceleration. Photonic chips may be especially useful for the repetitive mathematical operations required by modern machine learning. Future data centers could use photonic links to move information between processors, memory, and servers at extremely high speeds. Photonic computing could also support robots and autonomous machines that need to process large amounts of sensor information quickly. Specialized photonic processors could also help with scientific calculations, simulations, optimization from fast parallel mathematical operations. But building photonic chips is not easy. The optical structures must be manufactured with extreme precision, and integrating many components onto a tiny chip can be challenging. Another challenge is the light source. Photonic systems often need lasers and other optical components, which can add complexity, cost, and energy requirements. Photonic chips also still need electronics. Controlling, powering, and reading optical systems often requires electronic circuits working alongside the photonic components. As technology advances, we may see computers that combine electronics, photonics, and AI highly specialized systems designed for speed, efficiency, and massive. The big idea is simple. Photonic chips use light instead of electricity to process information, enabling much faster communication and transforming specialized computing. Photonic technology is already shaping the future, combining light and electronics to power faster communication and the next generation of computers. Thank Thanks for learning with Ethan. If you enjoyed this lesson, don't forget to like, subscribe, and turn on notifications so you never miss another easy-to-understand engineering video.